Today is the last section of material from your book. We still have a few days of some manipulative work that we're going to do after we get to that next week. But today, last section from your book. And this whole chapter 10, has been about statistics, creating graphs, looking at graphs, reading graphs, that kind of stuff. This last section, 10.4, that you haven't finished quite yet, has been about calculating some different values, the mean, the median, the mode, the range, the IQR, standard deviation, mean absolute deviation, percentiles, and a bunch of other things actually still too. So what we're going to look at in this section is abuses of statistics. In particular, what I'd like when you finish this section to be able to do is that when someone presents you with something, for you to look at it and ask yourself questions, does this make sense? As what I'm looking at really meet the claim that this person's trying to make? Or is there something funny going on? Okay? So there are two different types of abuses of statistics. One is called a sampling process abuse, and the other is a graphical representation abuse. So some problems with sampling that will sometimes happen is who was asked. All right? So if you want to know how Oklahomans feel about any number of political issues, and you stand outside of Emmanuel Baptist Church, you're probably going to get different answers than if you stand outside Shawnee Mall, right? Who's asked? In particular, also, how many are asked? So if I ask 12 people, or I ask 1,200 people, I might get different responses, right? How many people are being asked? How many responded? So you've probably gotten surveys in the mail or in your email or maybe even on your phone before where you've immediately deleted it. Maybe you got it at a restaurant and you just throw it away because you don't really need the buy one, get one free Big Mac from McDonald's, right? You don't even care about that bonus if you participate in their survey. So if they send the survey out to all these people, right, maybe like 5,000 people got the survey, but if only 10 people respond, that doesn't show very good response rates, right? So that can affect things. Was the sample random? So did they, like I said, stand outside Emmanuel Baptist? That's not a very random sampling. Or did they select every 10th person from a phone book? You guys probably know what a phone book is. They used to exist. Okay? How did they choose the people? Was it really random or was it a little bit tainted? And how was the question worded? So there are times when people word questions either in a way that's really confusing and you're like, I'm not even sure what you just asked me. So it's really difficult to make sure that the people who are responding know what they're responding to. Or they make it worded in such a way that you're led to a specific conclusion, right? Like if I look at my child and I say, did you steal that cookie? You know stealing is wrong. Do you really think they're going to admit stealing that cookie? Probably not going to want to do that. So if you're asking the question in a way that's condemning or that's trying to show some sort of a moral value to what you're asking, people aren't always truthful. So there's some issues with how you ask questions and how you collect data. Once you've collected the data, there's also potential issues in how you display it for others. So that's our other one, which is graphical representation. We talk about, making sure we have a title included. If you don't have a title included, you may not actually be looking at what you think you're looking at, right? So if I give you a grade distribution, how do you know that that's a grade on a quiz or an exam or a final course evaluation grade? Because it could quite represent different things. Having labels on axis or all sections of the pie chart, whatever kind of a chart or a key you're looking at, basically. So does the data sort of lack clarity? Source of the data being included. So not necessarily so much on what we present, but when somebody actually creates real data, and you'll notice it in the stuff from your book, there's usually a source next to it, and it says something like it was obtained out of this particular data set or this particular survey that was sent out by the Census Bureau or something like that. It tells you where it came from. So that gives validity to what you're looking at. Is it really real information, or did somebody just make these numbers up? It matters, right? A key to a pictograph or a stem and leaf plot. Again, you got to make sure you're knowing how the information is being presented. I've talked about uniform size of certain things, like when I talked about bar charts, when I talked about making sure your bars are equal widths, when I talked about pictographs and dot plots where we stacked the X's on top of each other, I showed you how you could sort of be led astray potentially if your symbols were not all equal in size. Do you remember when we put those little breaks on the vertical axis that showed that it didn't really start at 0? Well, if you leave that off, it can also be misleading because someone might really think that your x-axis represents a y value, whatever it is, of 0. Scale, are the numbers evenly spaced? Yeah, I already mentioned that one. And then the one I want to show you in particular with your textbook is the 3D and 2D misleading effects, because this one's really interesting, and it's probably not something that you've ever thought about before, and you're actually on exactly the right page, Matt. So it's 606. Turn to page 606, and there's a pie chart. That's the one I want you to look at. Okay, does everybody see that one? Okay, I'd like for you to look at what the percentage says in the green section and in the blue section. What percentages do you see? Ooh, careful there. What are the percentages in the green section? What's it say? 27. And what's the percentage in the blue section? 23. Those are almost the same percentages, right? Not exactly, but they're pretty close. Do those pieces of the pie look like they're the same size? They don't. They don't look the same size because of the angle at which you're looking at it, right? Somebody has taken something that's actually a very flat graph, if you drew it in a circle format like we did it, and they've three-dimensionalized it to look like something that's really not happening. Are you with me? That's a misleading effect. There's another one I wanted to show you, and it's the one right above it on the page, where it shows the orange square, or orange-yellow square, and the blue one. So this one is actually showing you that if you're measuring how many in millions of boxes, the little blue box is 2 million boxes, and the orange box is 8 million boxes. So if you compared the numbers 2 and 8, obviously 8 is 4 times 2, right? It's 4 times as big. But does that yellow square look 4 times as big as the blue square? Ooh, it looks way bigger because they've three-dimensionalized something that's really a two-dimensional description. You with me? Not only that, but they've actually also made it not just the depth, they've also made it wider. You see that the width of the boxes, not just, just the depth that's there, but the width as well. So those are 3D and 2D misleading effects. So what we're going to do today is you have your group work, of course, like we said, over section 10.4 that you're going to start with. And I want you to start with that too. But once you're finished with that, everything you'll notice on this page says that it's all group work / homework. In fact, there's no section C even. It's a section A, section B. All of these really are easier to work with when you work in pairs or threes or whatever, because you may not see something that somebody else sees, and it's just a really good group activity kind of thing, okay? So we're going to do as many of these as you can get to in order, because you are going to turn them in, but in order, and then at the end of the last 10 minutes of class, we'll do our presentation selections for the final presentation, okay?